everybody, welcome back. This is Alex Does Lead Code, and as usual, I do programming problems with you on stream. Now, as we started doing the last time, we we didn't actually do this together. Sorry. Um, I I would uh I would actually decide what problem to look at next at the end of each stream, so you know what I'm going to work on next stream. The way I'm going to start doing this, once I have the time to do it, is to actually put the problem on the YouTube thumbnail. This way, you can see a schedule for the next stream, and you'll see right away what problem it is, and you'll be able to work on it, try it out yourself before doing it with me. So this way, you have a bit of a few days to try it out yourself, get it right, get it wrong, and then we will work on it together. And you can look at my thinking, you can see what my thinking process is, and hopefully will not get stuck. Okay, so as we mentioned the last time, today we will be working on a problem called zigzag conversion. This problem, when I first saw it, I was really confused. I didn't know what it was supposed to do until I saw this example. So basically, it looks like what it's trying to do is that it is going to print the word given in a zigzag pattern. The zigzag pattern goes as follows. First down, and then down to up, and then down again, and then down to up, and then down again, then down to up. So, and the length of the zigzag is not immediately clear. It's not immediately it's not known a priori. Okay, and after you do this down to up, you then print each of these letters as they appear. Okay, so so there's two ways of doing this. I'm going to start from what I think is the sort of more intuitive way. I'm going to describe that, and I don't know whether I'm going to write the code for it. And then I'm going to talk about what is probably the expected way to do this problem. But let's talk about intuitive way first. So the intuitive way is to actually do the zigzag pattern and lay it out. And so what we'll do is that we'll create a 2x2 not 2x2, but a fairly large rectangular array, and we'll figure out the dimensions later. We'll create a large rectangular array, and then we will actually put the letters down. We'll actually put the letters down into the array. Okay? So the algorithm goes like this. You have a down phase, and then up, right, up and to the right phase. And then you put this in some kind of loop. So in the down phase, you print a letter, then move down. And so you keep like these, like x equals 0, y equals 0. And then you just go down and then go up. You know what? Actually, let me do it this way first. So we're going to try it both ways. As a teaser, I think there's actually a better way of doing this, because output we want is just the collection of letters here, 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 this, this. And we can actually calculate what these things are mathematically without laying out in an array, as I'm going to show you later. Okay? You can actually calculate these things mathematically. This is I plus, there's some formula there. And so unfortunately I didn't think about it much last time, but as you guys might know, I have a bit of a dislike for mathematical puzzles dressed up as programming problems. I don't think this is a programming problem. I think it's a mathematical puzzle. So if you do it the second way, basically you need to find the trick to calculate, this PINAL. You need P-I-N-A-L. You need to calculate. You basically take this and reshuffle into this. You don't even need the array. You don't need the matrix here. You don't need it at all. You can calculate. This I is actually this letter here based on the number of rows. And we're going to talk about that in a bit. But first, let's do it the quote-unquote right way, even though I know this is actually the wrong way. Okay? So we are going to do a while. We're going to have some kind of while statement. Okay? We're going to have x and y. And the idea is that x, you know, is x here and y is down. The idea is you print a letter onto the array. You have a large array. It's an array of arrays. So I'm going to write pseudocode here. I'm going to figure out what it is later. While something is true, you go down and then you move. And when you reach the bottom, so each time when in the down phase, you increase y by 1. If y reaches the bottom, then switch to up right phase. So same thing, print the letter y minus equals 1. Okay, so when y equals the bottom, you want to switch to the up and to the right phase. So y equals to so you go up here. Y equals y minus 1. X equals x plus 1. X plus equals 1. Okay, likewise. So if now y reaches the top, then switch to down phase. Okay, so we'll repeat this a bunch of times. We'll repeat this for as long as the letter, for as many letters there are in the word. Okay, that's the down phase, and then the up to the right phase, and then the down phase, then up to the right phase. Okay, I'm going to show you later that you don't actually need to do this, but I want to do this because I believe that this is an algorithm that will allow you to learn more about programming. The other way of doing it is a bit quicker, but all it does is teach you about math, and that's fine. Math is always good to use, but I'm gonna figure out what it is. Okay, we're gonna first figure out the size of the array, right? The height of the array. The height of the array is basically num rows, right? So if it's 4, it's gonna be of height 4. The width of the array. Here's the part that's tricky. Okay? Here's the part that's tricky. What's the width of the array? It's not gonna be the width of the string, right? It's not gonna be the length of string. But it depends on the length of string, and it depends on num rows. It depends on the length of the string, and it depends on num rows. Well, let's look at how wide this thing is. Okay, this is 1, 2, so like 1, 2, 3, 4, 5, 6, 7. This is width 7. Okay, it's width 7. So the way I like to think about it, and so when you see something like this, right? The general idea is you look for patterns, and there's a pattern I'm gonna see. So what pattern do you see here? What pattern? The pattern I'm gonna use a technology I've never used before. The pattern I'm looking at is that it goes down, and then it goes up, and then it goes down, and then it goes up, and then it goes down, and then it goes up, and then it goes like down, and then it goes up, and it keeps doing this. So this is a pattern that I can exploit. This is a pattern that I'm noticing, and one that I intend to do repeatedly. Okay, so now that I have a pattern that I can exploit, how do I exploit this pattern? Well, the way I'm going to do it is I'm going to first calculate the size of each of these down-ups. Right? I'm going to see how many letters are there in a V shape like this. And then I'm going to divide. I'm going to see how many V shapes this word can contain. That's a simple division. Of course, you want to round up. And after that, you just multiply by the width of the V shape. Because which V shape is, so each V shape here is 3. Each V shape, if I go up here, the V shape here is the same V shape. It's not as obvious because it's smaller. Okay, so each V shape here is it's basically width 2. So the V shape, so of V's. So again, this is fairly mathematical, it's fine. Okay, so the width of V, you'll notice, is basically num rows minus 1. You see? Because it goes down and then it goes up. This diagonal is of width num rows, but one side of the diagonal, this I over here, let me see. So this diagonal is always num rows, but one side of it belongs to it overlaps with the new diagonal. So we don't count this one. We just count P, we count PA, and we count L. Okay? We count PA and L. So width of num rows equals to num rows minus 1. Number of V's equals to, how many of these V shapes do we need? Well, first it depends. Well, that would be length of S divided. We're going to divide, get the quotient, and I'm going to add 1. Divide by the num letters in V, and I add 1 to it. That makes sense, right? In this case, each V has 1, 2, 3, 4, 5, 6. 6 letters. It has 6 letters. So I'm going to take the length of the string divided by 6. And I'm going to add 1 to it because this slash over here. This is actually quotient. So I'm going to add 1 to it. So for instance, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this guy has 14 letters. So the number of letters in each V shape is 6. You can count them. Okay? So 14 divided by 6 is 2, and 2 add 1 is 3. So you have 3 V shapes. Actually, it's 2.5 V shapes. So you can see here is actually 2.5 V shapes. 1 V shape. 1 V shape. And the third V shape is only like half filled. It's only got 2 letters. So it doesn't even have a V. But you know it's the third V shape. So we're again, we're trying to figure out the width of the matrix, right? So we need to do a bit of math. This is not exactly programming, but I think that math is important. Yes, it is an important skill to have. I'm not talking about mathematical techniques like calculus or linear algebra. No. I'm talking about the ability to combine simple mathematical operations to calculate the results that you want. So for instance, calculating the width of this, that's math. But it doesn't involve anything complex. It just requires you to plus, minus, times, and divide. This is an application of math. This is a tricky application of math. but the kind of math that it requires you to apply is very simple. Okay, just like programming is not about learning a lot of complicated moves and programming patterns and memorizing a lot of like language features. No. Programming is about the way you combine those features in a way that makes sense, in a way that gets the job done. Sometimes you'll be a little bit creative about it. That's the most important thing about programming. Not knowing what tools you have. Yeah, it's not knowing. It's not about how well you're good at holding how many pin brushes you have. It's about how you use that one pin brush. Okay, so number of letters in V is num rows. Okay, so this one is a bit tricky. It's so weird because we're still on the first part. We're calculating the width of the matrix, but but I promise you, this one actually will come in handy later. That's why I'm breaking it down. So, you see this V over here? How many letters is there in a V? Well, there's 1, 2, 3, 4. This is num rows, and then there's these two things here. So, what's the length of the uptick? This little tick here. This is num rows minus 2. So this is num rows, and this is num rows minus 2. Okay, so num rows minus 2. This little part here, num rows minus 2. That makes sense, right? Because num rows is, the height of this. That makes sense. And this one is also the height of this. The full diagonal is the height of this. But the first one was counted for here, and the last one was counted for in the next vertical. So it's minus 2. Just like how the width of V's is num rows minus 1, one of them is counted in the next vertical. So we don't count him, otherwise we double count. So it's num rows plus num rows minus 2. Okay, so now what is width? Width is number of V's multiplied by width of V's. Now, this actually overestimates the width of the array that we need. Okay, so we saw in this particular example, num V's is 2 point something, and we just round it up to 3. We are going to end up with a matrix that is big enough to have 3 V's in them. I don't want to deal with like partial V's, and I don't mind having extra spaces in the matrix anyway. I don't mind having a little bit, make the matrix a little bit bigger than I need it. It's better than making the matrix a little too small. Now, give me a second. I am going to fetch a drink because I am thirsty. Okay, I'm back. I got a cup of Diet Coke, which is definitely not what you want to drink in the morning. But I teach computer science. I don't teach health. So do what you want. Destroy your teeth. Okay, cool. So we have width and we have height. Okay, so now we have an array. So array is going to be actually let's make it like this. Let's make it like this. Times width. So we're gonna make a row, and then the whole thing how do I do this? Yeah, I do this, right? I'm pretty sure this is what I do. times height. I think this is what I do. Okay. You know, as usual, when you're not sure, try it out. Yeah, so 5 times 3. This is exactly what I want. Okay, cool. And these things will come in handy later. The fact that I make it, I thought about making a blank space, but that's not a good idea. That's actually not a good idea. Actually, you know what? It's not a bad idea. Yeah, it's not a bad idea. Let's make it a blank space first. Let's make it a space first. So the reason why I'm thinking about it is that if I make it a blank space, I'll be able to print this PIN with the correct number of spaces in between them. Okay? And then the idea is that after I do that, I can visually debug and see what's going on. After I'm done with that, I'm gonna turn this into like an empty string. This way it prints PIN. When I print the first row, it's gonna just print PIN, which is what I want. Just print PIN without spaces in between. And I'll just print row by row and we're done. Okay, so let's start with a space in between because I'm going to debug. And so, finally, we're done with the array. Now, let's do a while. No, I don't need a while. I need for. I need for character in S. I'm going to keep repeating until I got the whole thing done. So, x equals 0. Y equals 0. So, what do I do? So first I'm in my down phase, right? I'm going to use a boolean to keep track what phase I'm in. So if I'm in, let me see. So now I'm in my down phase, so I'm going to print. So basically printing is just y equals to c. And then if down phase else do this. If it's down phase, let's check. If it's down phase, then I have to do y plus equals to 1. If it's up to the right phase, then y minus equals to 1, x plus equals to 1. Okay, so the down phase again is when I'm moving down, and then the up to the right phase is when I'm moving up. Okay, and so the way I want it to work is that if I'm in my down phase, if I want to, because I want to turn, right? I want to go from down phase when I'm here. When I'm here, if y equals to num rows minus 1. So y is 0, 1, 2, 3. This is y equals to 3. We have reached the end. Then down phase equals to false. Oh, actually, I'll do it like this. There was a lot there. Okay, so basically, these if statements make the do the logic for turning. So when I reach the bottom, in my down phase, I reach the bottom, y equals to num rows minus 1, which means I'm right here at the bottom. I'm right here at the bottom. I'm right here at the bottom. Then down phase equals false. I'm going to switch phases. At the same time, I'm going to move x plus 1 and y minus 1. So I'm going to go up. I'm going to go up. So there's probably a way of rewriting this so that's a little bit more compact, but it's not coming to me right away. Is there a way to make this more compact? Because I'm sort of duplicating this logic, right? You get a lot of plus 1 minus 1s. Oh, you know what? I can do this instead. Let me see if this is easier. First, I switch. And then I don't have to do this check here. This might be easier. This might be easier, actually. So first, I check if I need to switch phases. Down phase plus 1. Okay, move to the next spot. Okay, cool beans. And you keep doing this until you've reached the whole thing. And so now, you join the array, right? You can join the array. Let's print it out. You know what? Let's toss the whole thing into Python Tutor. Num rows equals to 4. S equals to this thing over here. Visualize execution. Oh, oops. I'm sorry. You're zigging when you should be zagging. Zig when you should be zagging. Okay, cool. So something bad happened, I think. Array width height. Width is x. Y height is 2. So array is, what is this, 8? Oh, I can't do this. Wait a second. Oh, I can't do this. I'm not supposed to do this. Okay, so there are I did a few things wrong. So one, the most obvious thing I did wrong. The most obvious thing I did wrong is right here. Instead of xy, it should be yx. It should be yx. because array equals to a thing times height, which is, so height is the outermost array. I should change that. It should be yx. And then second thing I did wrong, and this is very subtle. Okay. Okay, this is very subtle. If you look at what's happening over here. I have a list of length 4. So this is supposed to be my height, right? My height is 4. And then my width is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have down, up, down, up, down. Yeah, this is perfect. So the width is correct. But notice so P comes here, but A actually took its spot. That's kind of funny. It's not supposed to do that. It's supposed to go to a next list. Now, the reason why P disappeared is because you'll notice that each of these 4 cells point to the same list here. So basically, what I've done in Python, lists are objects. Well, they're not exactly objects. But we have these references to lists. So essentially what I've done is I've taken with one list, I put the same list. I put the 4 references to the same list in an array. So when I multiply this by height. So I can't do it this way. I don't remember what's the idiomatic way. So let's Google it together. Python initialize 2-dimensional array. So there's a few ways of doing this. Okay, this is one of them. Aha! There we go. It's a trap. This is what we did. We fell into the trap. We fell into a trap. We said v times n, and then multiply that by n. So what that takes is this v times n, which is what we did. It's a trap. God dang it. Tricky. So v times n creates a list, okay? And then when you multiply that list by n, essentially what it does is it takes a reference. It takes quick. I'm in the middle of talking, dude. It takes that reference. It takes that reference and you multiply it 4 times. You see? 1, 2, 3, 4. They all point to the same list. So instead I want 4 different lists so I can go down and then go up. But instead what's happening is that they just replace whatever is there in the same list. So that's not what we want. So this is a trap. I'm supposed to do something like this. For I in range blah. So do this for I in range whatever. I'll just edit the thing here. Range heights. Okay, now this should work. Let's see what happens now. Okay, cool. So now this looks like it's working. So it says PAI SHIRIN. Oh, PayPal is hiring. I was wondering. Is PayPal hiring? Would I work for PayPal? Not right this moment. I don't know much about PayPal. Maybe I'll work for them in the future. Maybe it's a good place to work. Maybe it's not. I have no idea. PAYPALISHIRING. Blah blah. You see? So you'll notice that we have more space than we need, right? We have 4 by 8. We actually only needed 4 by 6. So we cut it off here. But it's fine. It's fine. Actually, it's not 8. It's 9. 4 by 9. It's fine. So I know that each V shape takes 3. I'm very addicted to this pen thing. I think I'm gonna get better at pen. Okay, each V shape is a width 3 boxes. So I have 3 V shaped 3 V's. So 3 times 3, that gives me 9. Okay, perfect. And so now, how do I combine this into the answer that I want? Well, it's not hard. Essentially, what I need to do is to first change this to... You know what? I'm going to leave this as a space and see what happens if I combine naively. So I'm going to combine equals... First, I'm going to combine all the inside parts first. I think it's s.join, right? I don't think it's s.join. I think it's like this. Let's stick this in here and run it and see what happens. Aha. So this is what we get. We get P space I spaces N, right? So why do we get this? Oh, actually, let me make this array 2. So this way we have both array 2 and array, and we'll be able to see the difference between the two of them. We have array that looks like this, right? And then we have array 2 that looks like this. So that's PIN ALSTI. PIN ALSIG. IG, sorry, not TI. Right? So it's joining these things together. Now, the first thing we didn't notice is these annoying spaces, which is why. So initially, I was just going to join them like this. I didn't realize we could actually print out a nice sort of rectangle this way. I want to visualize it using this. So to do that, I intentionally made this a space. So what I'm going to do now is to change this to this. And then when we run it, can we minimize this? We run it, we get this, which is exactly what we need. Now we just join this normally. Using the delimiter to join seems a little bit counterintuitive. I never quite agreed with this syntax, but I get it. It makes sense. Logically it makes sense. It just feels kind of weird, right? It feels kind of weird. Because normally when you call a method on something, you're calling the method on the main thing. The delimiter doesn't sound like the main thing, I know that join basically takes two things. It takes a string. It takes an array, a list, and the thing to join it with, the delimiter, or the thing to put between, whether it's a space or a comma or nothing. But I always thought of the string as the sort of main argument and the delimiter as a secondary argument. So the idea that you say space dot join, empty string dot join annoys me a little bit, but it's fine. Okay, so if I run execution here, I'm pretty sure this will work. Yep, and this is the correct answer. So let's take this here and run it. I don't even need a new variable. I just return. Okay, easy peasy, lemon squeezy. Flip this around, and then this thing, I need to for in range. Hi. Wait, what? Letters in V. Num rows. Oh, gotcha. Wait a second. So if num rows, what happens when num rows is 2? Wait, this is division by 0, which means num rows is... What happens when num rows is 2? When num rows is 2 is fine. That means num letters in V is num rows plus num rows minus 2. Yep, that's correct. I think there's a special case here. If num rows, I hate special case as a rule, equals 1, return S. So if num rows is 1, you just return the whole thing. I hate these kind of special casing as a rule, but yeah, but it's a bit annoying. That means I have to say, oh, no down face, blah blah blah. That's just annoying to me. Okay, cool. And let's submit. I think this should be slow. I hope it's slow. Yeah, it's kind of slow, right? It is kind of slow. And this beats 5.6, which means I'm all the way at the bottom. 95% of the people who submit this problem got a better solution than us. Let's take co-ownership of this. Okay. And the reason is because I actually created a two-dimensional array, right? So imagine if my word was extremely long, I need a giant array to make this work. Is there a better solution? The fact is, there is. I'm gonna go over this maybe quickly. I don't know. I don't want to spend too much time on it because it is actually a mathematical solution. And it comes back to the idea of these V shapes. Now, the end result that we need does not actually require us to print this thing out. Does not require us to print out the array. Instead, all it wants is to print this, and this letter, and then this, and this letter. And we can actually calculate these things mathematically using the V-shape, the same V-shape idea, right? I'm going to prove that to you by first making the simplest calculation. Okay? Let's not try to unravel the whole string first. Let's just think about it, okay? Let's think about it. Let's say the problem was print out the first row, which is P, I, and N. Can we do this without drawing the entire matrix? Can we? Well, it turns out we can. Because all we have to do is to notice this V-shaped pattern and then say, well, the V shape is 1, 2, 3, 4, 5, 6 letters. So I'm going to take the first letter, that's P. I'm going to add 6 to that. That is 0, 1, 2, 3, 4, 5, 6. That's S6, which is I, right? 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6 is I. And then 7, 8, 9, 10, 11, 12, which is this n here. Right? So we're using these mathematical properties to help us. So what's the pattern here? The pattern here is for the first row, pattern for the first row, you know what? I can actually write text here, right? Yeah. Pattern for the first row. And what's the pattern for the first row? Is 0, 0 plus let's call it size of V shape. 0 plus size 2 times size V dot dot dot. So that's the pattern for first row. Okay? Do we see that? That's the this is so annoying. How do I save? Okay, I can't. I can save. No, there's no what I want. Okay. Okay. Now it's gone. Let's see. Can refresh. Okay. Well, doesn't matter. So essentially, this wait, I can't even type. I can't type. Man, dude, you. Oh, blob. I see. Okay. All good. All good. No need to panic here. I'm not panicking. Alright? I'm not panicking. Okay. Alright. So, first row is just 0 and then subsequent size V. Right? 0, 0 plus size V, so on and so forth. Let's look at the bottom row. The bottom row, I like this because this V shape is a little bit bigger. Bottom row is this guy, which is basically, let's just call it SV for short. Size of V shape. Size of V shape minus 1, which would be this guy right here. His index. His size V shape is the fourth element, but his index is 3. So size V shape minus 1. And then subsequent SV. It's the same idea. Right? That's the bottom row. So P, I, and then whatever this is, right? And notice the way it works is if you run out of letters, you just stop, right? You run out of letters, you just stop. Now, the in-betweens. In between the top and bottom row. Notice the top and bottom row are a little bit different. For each V shape, there's one letter at the top and one letter at the bottom row. And there are 2 letters in the middle. One here, and then one here. But these middle ones have 2 letters per V. Right? You have A and L, Y and A, S and I, H and R. Whereas this guy only has P, I, and I'm talking about per V shape, okay? Talking about per V shape. So we're going to do this a little bit differently, which means that we're going to also need two things. So the first thing is easy. The first thing here is actually not hard. This thing is basically the index of the first, which would be, let's say, row R will be R, right? So row R, let's say this is 1, this will be R. And what is this guy here? Wow, I don't know what this guy is. This is hard to figure out. So let's start with the one at the bottom. Oh, actually, it's not hard to figure out. It is. We know what this is, right? This is SV. So this is SV minus row. SV minus R. This is SV minus R just before it, right? Row 2 is Y, and then SV minus 2, which is A. Okay? It's this thing. And then R, SV minus R. And then this, you just add SV to it. So SV plus R, SV plus SV minus R. So you see how this gets more complicated mathematically? You guys notice how this thing gets more complicated mathematically? So this, you can see, for instance, let me just explain this. Let me get done explaining this first. So look at this row right here. You have, I'm going to think of them as 3 blocks. Block 1, block 2, and then block 3. Okay? Each block, each V block has 2 letters. The first letter is row, an index row. And the second letter is at index SV minus row. So this is 0, 1. This R, this is row 1. A is index 1. And L is SV minus 1. It's 1 before I. I is SV. We know that from this one right here. 0 SV 2 times SV dot dot dot. Right? N is 2 times SV. So we have the next SV minus row. Okay? And then we just do all the middle rows. Now, this S here is basically A and L, the index of A and L plus SV. Right? So that kind of makes sense. Okay? So if we repeat this many times, oh, I no longer have the ability to not zoom in. Wait, how do I not zoom in? How do I unzoom in? Okay, cool, perfect. So now we have the pattern. Now with the pattern. The pattern is the difficult part. The easy part is actually writing it out. Okay? It's actually writing it out. So what we're going to do is, first, we're going to borrow a few things here. First, we're going to do this again. If num rows equals 1, return S. Okay? And then we're going to do number of letters in V. This is our SV. This is our SV. And I don't think we need anything else here. Number of letters in V. And that's our SV. Okay? So for 4, the number of letters in V is 6. 1, 2, 3, 4, 5, 6. And we get that by num rows plus num rows minus 2. We can just do 2 times num rows minus 2. Okay? So what we're going to do is first we're going to do our first row. So first row is very simple. We just do for I in range. We're going to do the step notation. So 0 and length of S. And we're going to step each time. We're going to step by SV. So this will give me 0, SV, 2SV, blah, 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 until I'm greater than or equal to length of SV. Okay, so I need a result. Plus equals to SI. First row. Okay, we're going to do the last row. It's the same idea for I in range. It's not 0 anymore. Length of S, SV. Result plus equals S of I. Okay, so it's a very similar idea. So it's SV minus 1, 2SV minus 1, blah, 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 blah. But instead of starting from 0, we are starting from SV minus 1. And so because num rows is guaranteed to be at least 2, num rows is 1, and I don't think num row is guaranteed to be, yeah. Right, so this is a little bit, yeah. So this handles the last row. So in between rows for I in range. So now we need R, right? Because there are multiple in between rows. So for the in between rows, it goes from 1 all the way. The first in between row is row 1 here, and the last in between row is num rows minus 2. So it goes from num to num rows minus 1. So yeah, notice it's not minus 2, because minus 2, if I do num rows minus 2, then the last number that I'll go to, let's say num rows is 4, right? I wanted to go all the way 0, 1, 2. I want to go to 2. If I do num rows minus 2, it's going to go up to 1. So I need to do num rows minus 1. And so this is in between rows. And so for in the in between rows, it's for I in range. So this is a nested loop. Okay, I'm going to say this guy and this guy, and I'm going to repeat it many times. So this guy is simply R, and then I don't care about this SV minus R. Okay, I'm going to keep doing the R. So same thing, length of S, stop when R is greater than S, and this increments by 1 each time. Oh, sorry, increases by SV each time. So it starts with R, and then R, which is 1, when 1 plus SV, which is this one. Y is at row 2, so it starts at 2. So H is 2 plus SV, and then 2 plus SP, 2 times SV. So you're starting to see how this problem is mathematically a lot more complicated than the way we did it before, right? Just think about the mathematics. This one has almost no mathematics. You see it pictorially, graphically, you just go up and down, and then you're done. This one has a lot more mathematics behind it. You have to think about, plus 1 minus 1, plus 1 minus 1. So I think that these problems, these kinds of solutions, this kind of solution, this mathematical approach, is a good practice for thinking about problems creatively. So it gives you good practice to attack a problem in a certain way, programming problem in a certain way. After all, in many ways, logic and mathematics are the foundation of programming, right? Notice we never use advanced mathematics. There's no geometry, there's no calculus. In our problems here, we don't do matrix multiplication, but that's pretty much the most complicated thing you'll ever do when you're programming. Instead, what we do a lot of is trying to figure out the patterns, and then using plus, minus, times, divide to sort of replicate these patterns. So that's the part that is a little bit complicated, okay? Figuring out the patterns and using mathematics to recreate those patterns. But it's not about what tools you know, it's about how you use them. You can see this sentiment echoed many, many times. Okay? So result plus equals. So this one first. Si. And then I'm just going second index equals to SV minus R. So this is R, right? So R is this one. So R is, okay, so SV is this one. SV minus R is L. Now I want to get to S to L. So it's basically R plus SV, which gives me to S, minus R, which gives me to I, and then minus R, which gives me to L. So it's I plus SV. I is here, plus SV gets me to S, and I'm going to minus SV, which gets me to I, and minus SV again, which gives me L. So minus 2 times R, sorry. So same pattern. Let's say R is 2, then we add Y, okay? So we're gonna oops. So we have Y. So we add SV, which will be here, minus R, which gives me I, and then minus R again gives me A. So I to A is R, I to H is R. So this would actually give me the index of this A here. So in the in-between rows, things are not the first and not the last row, in between rows, each SV, which each V block has 2 things in it. I want to calculate both things. If second index is smaller than length of S, then result plus equals S second index, else break, because we reached the end. Okay, I'm pretty sure this will work, but let's find out. Return result. Convert, yeah. Ha, wrong. Output. The last 3 letters are wrong. P, S, and I get Y, I, and oh, so my last row is wrong. P, S, and I. So what am I doing? Wait, why is this wrong? So notice I got the only thing I've got wrong is the last row. P, S, and I. P, S, and I. It should be P, S, and I. Why is it? What should Y, I, and R? Okay, this is when num rows is 3. So my first one is P, so num rows. What's SV? Oh, it's not SV minus 1. It's actually not num rows minus 1. Gotcha. Num rows minus 1. Okay, perfect. And let me submit it to see what happens. Okay, so you see how I use a lot less memory, and it's actually a lot faster too. So now I beat 85% of people with Python, whereas the last time I tried it, I beat like 5%. So 95% of people used more memory than me. See this? See this big improvement? Because basically this strategy uses almost no memory and is faster. Okay, but why am I not jumping to this right away? Because I feel like the lessons that you learn from doing it this way, is basically how to analyze something mathematically, finding a pattern and repeating the pattern. Okay, the lessons they learn from doing this is programming. You see how the down phase and up phase, you sort of like wrangle these parameters. Yeah, and then this little join here, which is very useful. Notice how the difference between space and empty string. So these are two different approaches to solve the same problem. This is, in real life, I'll probably use this. Well, I definitely use this because it's faster and it's cheaper and it's all these other good things. But because this is a teaching exercise, I'm trying to teach all of us how to be better programmers, not just better mathematicians. I decided to start with this strategy first. Okay, and that concludes our stream for today. Before I go, let me just pick out the next problem to solve and put it into the list. Okay, how do I do this? Problems. View 150. I'm going to figure out a study guide. You know what? I'm going to figure out a study guide next time so we're not just jumping around. I like mediums. Medium seems just about the right level of difficulty. There's something to learn there, and it's not so difficult that, becomes a trick more than some of these hard problems are fun, but they feel like tricks. You need to learn and you need to figure out the mathematical trick, so it's a puzzle. It's not a programming exercise. I want something with a little bit more programming heft. This way we can go through programming techniques. We can go through good programming habits. Okay, wow. Valid Sudoku. Spiral matrix. Let's check this valid Sudoku. I like Sudoku. Okay. Determine if a 9x9 Sudoku board is valid. Only filled cells need to be validated according to the following rules. Okay, so you're not solving the Sudoku. You are validating if Sudoku is correct. This one I like because I don't think there's any mathematical trick. And there's quite a bit of programming to do. Yeah, there's quite a bit of programming to do. It's not hard, it's just complex. And that's exactly the kind of problem we're going to tackle. So let me just save this in a list. How do I save again? How do I save? Wait. I forgot how to save. How do I save this? God dang it. There we go. create a new list and practice using a list. No, I want to just save. What the heck? Dude, this is not helpful. From here? Wait, no way. How do I save this? Oh, add to list. There we go. Add to it. Add next. Okay, done. My list, refresh. Okay, so next time we're gonna do this valid Sudoku. Alright, so that's it. That's it for me today. Thank you all for joining me on stream.